What's going on, my friends? So what we are going to be doing today is talking about moving two electrons. So let's go ahead and take this reaction that you would see in your organic chemistry class, where we're going to take this alkene or carbon-carbon double bond and we're going to add an H and a Br. Now, a lot of students tell me that it's kind of challenging to figure out where the heck are all these lines coming from. So we're going to break this down into dots to kind of make it a little bit, make more sense. Just tripping over my words. So let's go ahead and drop this up in the top. And now let's go ahead and redraw the molecule on the left in this structure right here with all the dots. Now what we're going to do here is I'm going to take the two red dots that I've highlighted and I'm going to turn them. Think about it like a door. We're going to move it like a door out. I'm going to shift them out. So now the carbon on the left has the two red dots and the carbon on the right is not associated with those anymore. So what does that do? We've talked about this before, formal charges. The carbon on the left now has an extra electron around it, so it's going to be negative, and the carbon on the right has one less. So therefore, if we looked at formal charges, the carbon on the left is going to be negative, and the carbon on the right is going to be positive. So we could break that up into pluses and minuses. Let's do the exact same thing with our HBr molecule. So if we took this, instead of now taking the electrons and swinging them out like a door on a hinge, let's break the atoms apart, which you would know from Gen Chem, where this is an ionic molecule. So we're going to take the H and we're going to separate the H from the Br with the two orange electrons. So if we wind up doing that, now we can see for the same reason that the H now has lost an electron, which is going to be positive. The Br has an extra electron around it, or dot. It's going to wind up giving us an H with a plus and a Br with a minus. We've talked about this before, but you can kind of get a sense of how we can start to create these charges. Now, if we just left it at this right now, we could do this simply based off of the foundation of organic chemistry, which is what? Minus goes to plus. And then from that, we could basically see, okay, cool, the carbon with the negative is going to be associated with the H, and the carbon with the positive is going to be associated with the Br, and we can see that's going to be the actual product in our top right side. But what I want to do is I want to go one step further and show you, just based off of the two electrons, what the heck is happening here. So if I took these two molecules, and now if we were to look at the carbon on the left, we can see the carbon on the left has quote unquote 4 bonds because it has the 2 electrons. It just needs the red electrons to actually plug into an atom. So we actually have a bond. Right now we just have 2 electrons. That's why it's negatively charged. If we look at the carbon on the right has 1 less. That's why it's positively charged. It's looking for something to plug into it. So you're going to see here the red carbons, the red electrons are 2, the orange electrons are 2, and it's all about plugging in the appropriate spot. So if we look at this, what I'm going to do is I'm going to take the bromine, I'm going to rearrange the orange electrons so they point down. Doesn't matter where they are, we just need them associated with the bromine, and you can imagine I'm doing this because it makes it easier about what I'm about to draw. Now let's focus on the hydrogen. So what's going on here is the carbon has the electrons necessary to plug into something, it just needs an atom to plug into. So we can see the red electrons can plug into the H, like we see here. And then also the orange, we can see the carbon at the bottom on the right doesn't have electrons, so it needs something to plug into it. And so therefore the bromine has the extra electrons. I'm tripping up on my words, so it can plug in. So you can see that all this is about right here is finding where are the 2 electrons that are going to plug in to an atom.